Hi, this is Chris from HITI Software. In this tutorial, we are going to see how to use the Arduino data control panels to build a user interface to control and monitor your Arduino projects. Today, we will focus on how to implement virtual switches, virtual buttons, set points, indicators, and metrics. And in the next tutorial, we will see how to link virtual switches, buttons, and set points to manual commands and facial expressions. Okay, let's open the Arduino data control panels. These panels display the values of digital data and analog data which were created by our Arduino library to allow interaction between your Arduino program and HITIBrain. The main idea is that you can set the value of the data from your Arduino program and read this value from HITIBrain. In that case, the data will be used either as an indicator or a metric in HITIBrain. And inversely, you can set the value of the data from HITIBrain and read this value from your Arduino program. In that case, the data will be used either as a virtual switch, a virtual button, or a set point in HITIBrain. There are 32 available digital data and 20 available analog data. Each digital data holds a Boolean value and each analog data holds a float value. Now let's close the COM port in HITIBrain and let's go back to our sketch, the one we called My Sketch. If you closed it, you can reopen it by clicking on Open and then Open Sketch here. Now uncomment the code we commented out last time. So there is variable click counter, and inside the loop we have this whole code snippet here. So remove the /* and the */ at the end and upload the code. Now go back to HITIBrain. Go to Settings and unlock the user interface. We want to display only data 0, 1 and 2, so let's do that. And let's give them a name that will reflect how we will use them. Digital data 0 as an indicator, digital data 1 as a virtual switch, digital data 2 as a virtual button, analog data 0 as a metric, analog data 1 as a set point, and analog data 2 as a metric also. Now open the COM port. You should see the metric of the elapsed time in milliseconds starting to increase. And once it reaches 10 seconds, the indicator on the left should turn on. If we look at the code at the beginning of the loop, we can see that we use function millis to get the elapsed time in milliseconds since your Arduino was powered on or reset. And we write this value to analog data 0 so that it can be read from HITIBrain. Just above, we also see that we create a Boolean variable that gets true 10 seconds after your Arduino is powered on or reset. And we write this Boolean value to digital data 0 so that it can be read from HITIBrain as well. Next, if we click several times on the virtual switch, we can see that the servo on pin 8 will alternate between two positions. If we look at the code, we can see that we read the Boolean value of digital data 1 that have been set from HITIBrain, and depending on this value, we move the servo either to position 169.3 degrees or to position 12.8 degrees. Next, let's have a look at the set point. It is used to set the intensity of the LED on pin 5 between 0 and 100%. So this input is expecting a value between 0 and 100 and will reject any value outside this range. For instance, if I try to put 150%, I will get 100. I can check that I do get the max PWM value for pin 5, which is 255, so good. And if I put 50%, I will get 127. If we look at the code, we see that we start by reading analog data 1 to get the set point value set from HITIBrain. Then we constrain this value between 0 and 100. And then we write this constrained value back to analog data 1 to update the displayed value in HITIBrain. Finally, we map the value from the range 0-100 to the range 0-255 before applying it to the PWM output on pin 5. Okay, next, if you click on the virtual button several times, you will see the click counter incrementing each time. If we look at the code, we can see that when we detect a click on digital data 2, variable click counter is incremented, and its value is returned to analog data 2 so that it can be displayed in HITIBrain. This concludes this tutorial about how to use the Arduino data control panels.